Welcome to another exciting episode of the NIDS View, a weekly show of the National Institute for Deterrence Studies, where we are advancing peace, promoting stability, and helping you to think deterrence. Each week, we discuss and analyze a recent topic and provide insight into how it affects our national deterrence. We hope you enjoy this show.
Welcome back to the NIDS View. I'm Jim Petrosky, President and co-founder of the National Institute for Deterrence Studies, and your host today. For those of you expected to hear Adam Lowther, who traditionally hosts this show, both he and Curtis are on assignment at the STRATCOM Deterrence Symposium, and I'm certain that by now they're interacting with the many deterrence experts there, getting up to speed on the newest things, and likely enjoying a few adult beverages. That's okay with me because I now get to choose the topic and the guest for today, and we have a great show in store for you, not because of me, but rather because of the topic and today's guests. Joining me today is Dr. Wally Clark, Senior Fellow at the National Institute for Deterrence Studies, electromagnetics and electronics testing expert, and a longtime friend of mine. Welcome to the show, Wally.
Thanks, Jim. Good to be here. I hope we can talk a little bit about NC3.
Well, that's where we're headed today, and so we're gonna get there shortly. Also joining me today is Chris Stone, also a senior fellow and a host of the Real Space Strategy podcast on the NIDS podcasting network. If you haven't heard Chris's show, you're missing a great education on the future of space operations. Welcome to the show, Chris.
Hey, thanks very much. Appreciate it.
All right. Well, let's go ahead and get started. So today we're going to discuss the modernization efforts of the Nuclear Command, Control, and Communication System, better known as NC3. And we're going to discuss this loosely based on a recent set of papers that were put out on the issue brief called The Modernization of Space, Nuclear Command and Control from the Atlantic Council. And so what we're going to do today is have a discussion, hopefully a lively discussion, about the nuclear command and control system. And so to lay out a little bit of the basis here, we're going to look at the NC3 system, which is basically the protected and assured missile, air, and space warning and communication system that enables our command and control of our nuclear forces. And it must operate effectively in some of the most extreme and existentially challenging conditions. And it is basically for the employment of our nuclear weapons. And so this system has a lot of detailed requirements that start out with detection, go to warning, attack characterization. It has to help with adaptive nuclear planning, decision-making, conferencing, receiving, and executing the presidential orders, and also enabling the management and direction of our forces. And because of that, extreme conditions, and because it is using space, I have Chris Stone and Wally Clark here today. So to begin with, I want to start out with a little bit of a discussion of this system that was deployed back in the 1960s. And that's why it needs to be modernized. And so I thought I'd start out with Chris Stone, who's looked at space from a modern standpoint and our view of space and its applications, and sort of bring the audience up to speed on where space was in the past and where we are now, and what might provide those new challenges to NC3. So, Chris, I'll turn it over to you.
Sure. Well, I appreciate that. So if you look back at the early days of the space age and the nuclear age, obviously one of the main reasons that they created the space program initially was to prevent a nuclear Pearl Harbor, as they called it. And so a lot of the early committees that were trying to figure out how we're going to use space as part of the Strategic Air Command at the time's nuclear deterrent force was, first of all, to have some ISR capability. So the ability to collect intelligence, surveillance, and reconnaissance. So the early Corona program was the first of that. And so we started orbiting those around the Earth, particularly over the Soviet Union and China and other places that became more of a threat. And then over time, as space became more and more accessible for us and our technology advanced, we added several other additional capabilities to include signals intelligence, satellite communications, some of which are multiple different bands. So you had UHF, you had SHFs, and then you have extremely high frequency EHF eventually coming online later on. And each of those are meant to be secure in their own right, some more secure than others. And each of those, if you've ever been a missileer or worked on alert in a bomber unit, you definitely are familiar with all those comms. And then also, probably about the late 60s, early 70s, we started deploying the first batch of missile warning and detection to complement and to increase the time of warning that our ground-based radars could provide. Because with the advent of the ICBM and the submarine launched ballistic missile in the mid 50s, you started having a situation where you didn't have hours of warning anymore. You were down to like 15 minutes to 5 minutes, depending on if it was an ICBM from a land base somewhere in the Soviet Union or if it was coming from a sub. And so, in order to expand that warning time to be able to make decisions as part of this NC3, as it's called, system now, then we created a satellite system that was able to detect that from high orbit called geostationary Earth orbit. And as a result of that, we were able to learn how to use those things all throughout the Cold War. But one thing I will correct you on is that these satellite systems that were began in the 1960s have been evolved and developed over time and updated as time has gone on. So while we had many satellites like Corona and Grab, now we have numerous new ones to do the ISR mission. From a missile warning standpoint, we had the Defense Support Program, and now we have the space-based infrared system called SIBRs, and now we're looking at the lower orbiting proliferated constellations that space development agencies working on to do space warning and excuse me missile warning and tracking to be able to get after the hypersonic threat as well as the standard traditional ballistic missiles and submarine missile threats, and then also possibly some higher orbit vehicles to replace the old systems that have been around since the early 90s and 2000s. So we've been updating these over time for various purposes. And then finally, there's a global positioning system, which also has a dual mission as a nuclear detection system that's open source. And basically, they're there to make sure that if there's any issues
That's good.
out there, that if someone detonates a nuke or tests one up in space, then we'll be able to test it, or we'll be able to sense it rather, and all that. So with the newest form of GPS-3 coming online, that mission will probably continue into the future, as well as in other things that we can use to detect that stuff. And so all these systems have been developing over time and enhancing as technology advance, and it's continuing to be a key part of NC3.
So, Chris, I appreciate you correcting me, and I'm familiar with DSP because I know that we've been relaunching and applying technology into DSP satellites, especially because I've spent a little bit of time looking at how we can detect nuclear weapon detonations. But if we've been modernizing piecemeal as we've moved forward, then what is the purpose behind the current modernization effort? And I'll get to Wally here in a minute because things have changed dramatically over time. But Chris, can you sort of answer that?
Yeah, so initially, you had the Soviet threat and sometimes Chinese threat, depending on who you ask, with regard to our ground-based system and then our space-based missile threat warning system. But basically, after the first Cold War, as I call it, went away supposedly, and our main adversary, the Soviet Union, went to be no more, and China hadn't quite gotten to the point where it is now. It wasn't looked like that we really had any need to build anything super sustainable, super survivable, as a lot of our systems were being looked at in the early 80s to try to find ways to make it defensive against the potential anti-satellite weapons of the Soviet Union and things of that sort. And so we had a nice 15 to 20 year respite where we just kept doing business as usual, and then we even started using our so-called strategic space assets for tactical purposes with conventional forces beginning in Desert Storm and forward through the 90s and early 2000s, to where now a lot of those perceived red lines that people still somehow believe is in existence, which I can give you reasons why I don't believe it is, Now we have hypersonic threats coming back. We have low flying missiles. We have hypersonic glide vehicles. We have the return of the fractional orbital bombardment system, which is basically a modified missile that can send a payload, nuclear or conventional, at a most of an orbit around the Earth, or it could be placed in orbit and deorbited, possibly going into one of our warning hole areas, the holes where we don't have good warning coverage, and possibly come in low and take out ground stations or other radar systems, and cause us to be blind before a massive or even a limited strike can happen over the poles or from the ocean. So because of all these different things and the advent of anti-satellite missiles and other weapon systems that the Chinese in particular and the Russian resurgence, even North Korea are pursuing, and possibly even a nuclear ASAT coming back again, just like it was in the 60s, that because of all these things, that the way that we're looking at how we handle the threat to our space-based assets is now becoming more of an issue than we thought it was going to be, because we figured peace was at hand and we didn't have to worry about anything but maybe a rogue nation or two and some terrorist organizations. But that's clearly changed.
Yeah, no, thank you. No, I find that the space usage, and especially the requirements to cover multiple sites, has really changed the strategy substantially. But I want to back up to the technology piece, and Wally, you've done a lot of the testing and evaluation, especially of electromagnetic pulse and electronics in space as well as terrestrially. Because NC3 is not just a space-based system, obviously has to communicate to the ground, be able to operate in communication so we can direct forces, et cetera. And I want to sort of go, use the Wayback Machine and think about how we've been testing and evaluating the system in hand, and then how we're moving forward. Can you sort of comment on what's been, what it was like to do it in the past and where we might be heading at present based upon your knowledge?
That's quite a question, Mr. Peabody. I'll see what I can do to answer it.
Thanks, Wally.
Yeah, well, you brought it up. So in the old days, remember, everything was analog. And analog has some strengths and some weaknesses when you're looking at, as you said, electromagnetic pulse effects. So in the old days, we used to test a few systems, and those were tested at the Air Force facilities at Kirtland, at the Trestle and the Dipoles facilities, some radio systems. Although I don't remember any satellites coming in for tests, which would be very interesting. Remember, when you test, when we tested then, you're really only testing a few systems, not the whole system of systems. So this brings us back to the old days where we had the large ground stations, which are being fed by probably commercial power and maybe a backup unit, talking to one or two satellites. And now, as Chris just said, we have tens to hundreds to more satellites trying to communicate to the ground systems. Now, that redundancy in space is great, because if one system sees a launch or a detonation, it can communicate to the other systems. But I wonder how many systems we have on the ground to listen to the warnings from these satellites on high. That worries me. Again, in the old days, we had analog systems. They tend to be inherently hard to some electromagnetic pulse effects. With new digital systems, especially the smaller systems that are getting down to the 2 nanometer scale construction level within an IC, integrated circuit, EMP can take advantage of an inherent weakness in the system. And I'm worried about that. And by the way, who do we buy most of our chips from? Not the United States. So do we test them? And also at the same time, I know this is not answering the question you asked, Jim, but this is just burning in my mind. When we test a chip, that's great. And we have to test hundreds of chips. We have to do a lifetime buy and store them so that if we only ever need 1,000, we buy 10,000 so we can test 2,000 over time. And we always have spares of our thousands. Those are hard to get. A chip manufacturer doesn't want to make a chip, just 10,000 of them. They want to make 100,000, 200,000. Buying Millions. For the government is just difficult. And then finally, chips are moving away from being purchased for a specific use. Now they are chips that can be reprogrammed in the field. And the worry with that is, how do I know that the chip manufacturer didn't automatically program the chip to reprogram itself in the field? There's a lot of problems here with NC3 that are not necessarily, that were not talked about in the two papers that we looked at here before we began the discussion today.
Yeah, I see that. It's sort of a two-edged sword from my standpoint. So you think about it, we're putting more satellites in space to be able to cover a larger geographical location. That also allows us to detect sooner and faster, but also puts more vulnerabilities in space. It does give us the redundancy. So, I mean, it's, from an engineering standpoint, you're looking at both sides of this. It costs, you got to manufacture them more quickly. You got to be able to put them into space more quickly. And even in this article, it says, how are we going to be able to do this with, daunting, they use the word daunting challenges, in modernization. And I'm not sure they're daunting challenges necessarily. I think they are challenges. Every engineering work has a challenge. And focusing on what the mission is, which is to provide for a system that can verify a launch, can verify a potential nuclear adversary's movement, and then be able to make a decision that is a positive decision to say, this is in fact a nuclear weapon attack that we must respond to, and then direct those forces with the presidential authority that is required, is important, both from an operational standpoint and from a deterrence standpoint, because our adversaries have to know that we mean business and we're putting those systems in space. And so, I turn it back around, on Chris's correction to me, and I'm not saying that was wrong. I like using that as a feeder here. So we've been modernizing many components, the NC3 system, but don't each of those steps also elicit a concern that we might put something in space that is not tested, not challenged until the time.
Exactly.
Yeah, until the time that we really need it. Because this is, someone once told me, imagine sticking needing something like a tornado's coming and you need your car. It's been sitting in your barn. You haven't used it. But in the NC3 case, we are using these systems on more or less a daily basis, just not under the austere conditions. So, Chris, I'll go back to you. Where does that redundancy lie in an operational, cluttered space atmosphere where we have adversaries that are looking at not only nuclear weapons in space, but kinetic and fraction? You might be able to correct me on this as well, Chris. So educate me. Kinetic weapons, but also fractioning systems, which can fracture in space and then take a large swaths of space usage by simply releasing a lot of for no other term than maybe flak into the space orbital arena, which we must be able to contend with to take out those eyes and ears of an NC3 system. So maybe you could sort of approach that, because to me that's the operational space mission, in addition to all the ISP and everything else we've talked about.
Yeah, the thing I'll just make two quick points as a lead into the answer to your question that Wallace and you have said about chips, for example. When it comes to space design, we've designed the spacecraft over all these modernizations I told you about since the 90s to withstand the space environment. And at higher altitudes, when you're above low Earth orbit, you're in a more higher radiation environment than you are within the Van Allen radiation belts, which kind of makes some of that less, right? And so you have a requirement for what's called rad-hard microelectronics, or ROICs. And basically kind of what Wallace was talking about, only he's talking about it in different respects. I'm talking about it from a spacecraft design. And that is, how do you get someone to build that many of those things in a way that will survive not only the space radiation environment but potentially a nuclear type environment in space? And so there's been discussions that I've been working on again, off again for about 15 years since I've been in DC, that people have been discussing, how do we get a trusted foundry, as they call it, in order to get these red-hard microelectronics fixed? And how do we keep it in the United States and make it commercially viable so it can do more than one or two things, but they still have the ability to make them the way we need to? So all those modernizations that I talked about were not for a high-end threat environment because they thought peace was at hand, right? Everything was going to
Right.
be good to go, and it was long-term future, if anything, and we could fix it. So what we did is we just kept improving the technology. We did not improve our tactics, techniques, procedures. We did not change our strategy per se until about '07 when the Chinese started testing kinetic ASAT weapons. And even then, it took till 2014 before people started taking it a little bit more seriously. What I would say is there's a quote from General Tommy Power, who was in charge of SAC back in the 60s, to your point about operational testing. And he would say, even today, we haven't tested the entirety of the NC3 architecture operationally at all. So
Yep.
we haven't fired missiles. We haven't in an operational capacity with actual detonating bombs, which that's a policy decision. We haven't launched all of our bombers and tested all of our communications in that kind of a degraded environment. And the reason why is because so we've had to do a lot of modeling and simulation. We stopped nuclear testing decades ago. We stopped doing all these other things. And so as a result, we have to do modeling and sim, and that's great. But when you're dealing with a threat environment that includes EMP, nuclear weapons, fractional orbital bombardment, space to ground attack, ground to space attack, and space on space attack, which is now a real thing, despite a lot of people, even in our own DoD's best efforts to try to put look the other direction and assume it'll go away. It's not going to go away. And in one of the reports that you had me read, they have a quote from General Saltzman, who's the chief of space operations for the Space Force, where he's talking about how many satellites in a 400 vehicle NC3 constellation would the adversary have to shoot down, related somewhat to General Hyten's, quote a couple years ago about, we have 4 or 5 missile warning satellites. They're big, fat, juicy targets because the Chinese can range all major orbital environments. A lot of adversaries can range low Earth orbit, which
Mm-hmm.
is anywhere from 60 miles up to several thousand miles with just basic missile systems. And so the fact that we're putting all these things into a low Earth orbit environment because you have to in order to get that kind of ability to see and sense such low intensity heat signatures, or you have to build a humongous sensor that can do it from higher, and that creates weight, which launch and weight is still a big deal. But anyway, he says that China, basically what he was talking about is like, hey, if we have 400 of these things, which Space Development Agency's National Defense Architecture is supposed to have several of these, and they're supposed to be able to take out several of them, and it's supposed to rebaseline and still function. Whenever I've asked that question to engineering friends, they never give me a straight answer, and I'm not even sure they really know the answer, quite frankly. And even if that was the case, the Chinese have already moved beyond targeting individual satellites. If you look at their own writings and their own doctrinal
Right.
shifts, and I've talked about this on my podcast and in some of my articles, is they're already looking at toward what they call systems destruction concept, which is you look at the entire constellation as one target rather than 400 targets. And so as a result of that, you have a multi-layered attack architecture that includes nuclear detonation and EMP if they want to go that high. They want to maintain escalation dominance. That's how they understand deterrence to be correctly, despite, in my view, our best efforts to redefine it to fit a world that we hope that we live in rather than the real one we live in. And so rather than moving everything to low Earth orbit, disaggregated, proliferated architectures that's supposed to be more resilient, and some people calling that deterrence, which it's not, or defense, which it's not. I think they should consider multi-orbit and have some defense in depth, because again, everybody's putting everything into the low Earth orbit proliferated basket, and I think that's
Yes.
not really helpful. Um,
Yeah.
does that help your question?
No, Chris, this is exactly right. Go ahead, Wally. You're about ready to say.
So that's a good way to look at it. A lot of observational capabilities in space, hopefully talking to enough systems on the ground that can communicate with the president, the joint chiefs, the secretary, and the missileers. So, and that's one of the things that I didn't read in these articles. I think it's wonderful that we have a spaceborne NC3, but you also need to have a ground-based NC3, because just because the satellites picked it up and talked to the folks in Washington D.C., that doesn't mean that the folks in Montana are ready to do the work that they need to do.
Yeah,
Well,
well,
certainly,
I'll just say that the ground infrastructure is connected to the space
yeah.
infrastructure, but
Right.
the problem is
But it's
making sure
legacy
that
as
it's
well.
yeah, and they're trying to upgrade some of that, but as you've seen, a lot of our ground systems are taking forever. Like just GPS. I was joking with someone at work the other day that the OCX system, which is their operating system, ground system for GPS 3, which I'm a lieutenant colonel. I'm in the military on the National Guard side. It's not my full time job, but still, I had an OCX program coin from a friend of mine when I pinned on captain, and I'm a lieutenant colonel, and
Mhm.
I've been
Yeah.
one for several years, and I have a lot of lost hair to prove it. So it's taken forever. So it's a matter of getting that. And in fact,
Yeah.
to your point, Wallace, that proliferated missile warning and tracking also has a low Earth orbit, slightly higher up, but low Earth orbit communication network that's supposed to help all these other several hundred satellites talk to these several hundred satellites that are supposed to go down to a main ground station and then somehow go out to other entities and users that might need it. I haven't really seen how that works yet, but that's what they're talking about. So whether it works, I don't know. We'll see about that, but
So what
that's
I'm
the
seeing
plan.
in my mind is a network. You have a net in space of the satellites that can all communicate if everything's working. All right, that sounds, and that is the way to go. That's very
Yeah,
good.
that's the idea. But again, my argument is that's great, but what are you going to do when the Chinese take it out or take sufficient numbers of them out? Because you're phasing out the old systems that are higher up in space, and you're putting everything down low, with a few minor exceptions. Thankfully, I did see that they're starting to talk about medium Earth orbit and a
Yeah.
few for geo. But Congress has been believing, oh, everything needs to go in the low Earth orbit for everything. NC3 weather, everything. Let's just put everything down there because it's cheaper, it's quicker. But the cheaper, quicker approach, the design, as I've heard, is as they replace it every couple of 2 to 3 years. And a conflict that deals with space and nuclear weapons may not take 2 to 3 years,
Yeah.
right?
Yeah. Well,
So
well,
go ahead.
Chris, I would say though, from looking at it from an engineering standpoint, there's some validity to the low Earth orbit work, especially because it is cheaper, easier to get something into space. I don't need it to be on in orbit for a long period of time. I can launch something today that is using today's technology. And 2 years from now, when it's starting to fall out of its orbit, I can replace it with something of tomorrow's technology that hasn't been invented yet, that may be more robust, maybe more capable, may provide me more information. So there is some validity to that.
Mm-hmm.
I'm one of those, Curtis is not here, but I'll use Curtis's answer with the, whack-a-mole theory. And that is that you make your targets so that you use what makes sense today, but you hold on to what's around from before. You give multiple targets to give you multiple options in these great scenarios. So high Earth orbit, low Earth orbit, geosynchronous orbit. You have stations that are in different places. So you'd have to take out the whole of the network rather than just a piece of the network, which is where the redundancy plays out. And
Right.
that is a way to employ. Wally was talking about these rad hard electronics or these new integrated circuits that may be tremendously hardened, but may not be at the technology level where we can field it today, but maybe next year or the year after. And so how do you get that into space? My view on satellites, and when I've worked with satellites, is by the time you space certify a satellite to get off the ground under normal government controls, it is outdated technology before it hits the launch pad. And that's part of the problem, that we need to find a better way to get things out there and get them into the air to support this NC3 system. And that's sort of the conundrum. So maybe smaller, faster, cheaper is good in the interim. And that's why I poked at you earlier on, Chris, is we've been modernizing, and I know we've been modernizing our satellite systems. So I'm very familiar with the DSP work. And
Yeah.
it certainly has been, that has been a great technology challenge, but also an incredible feat in our nation to be able to launch those satellites and put them into place. But the real result is you've got an adversary that's moving ahead of us, and they don't have the logistic chain. They don't have the decision chain. They have the internal and integral manufacturing capability. So how do we overcome that? And I want to end this show with at least an assessment of how you can get there and stay ahead. Because today, whatever we're launching today, we're already behind. So we have to acknowledge that.
Yeah, and I would say we have been exploring that using OTAs or other authorities, other authority. I forgot what the T stands for, but other authorities to acquire things quicker. And I'm not arguing against the engineering argument of the 2 to 3 years. That's definitely better than 10 to 15, as most
Thanks.
of our
You're
legacy
going to hurt
program.
you're going to just destroy me as an engineer to tell
So
me you didn't like us.
I love you. I love that idea. I love the increasing the time. My argument against the 2 to 3 years not working was from an operational warfighting kind of concept that
I agree.
if it's because even though we were now increasing our launch rate to 2 or 3 a day, which that was unthinkable just a few years ago, we're still not really that whole idea of me relying on reconstitution is not really valid and realistic yet. And as a lot of people have said over time, you have to go to war with the force you got. And the Space Force, we don't have what we need in order to do the support missions to NC3 like we should. And we don't have the ability to defend the infrastructure in orbit that people like Stratcom and others are relying upon. And I just think that it's good to understand from a strategic standpoint what the adversary is doing and not just look at it from an engineering problem, which for some reason, it seems to me that a lot of our decisions have been made on technology and not based on strategy, which I think could help a lot better if we would get a bigger picture. And I know we don't have that problem here at NIDS, but I have seen it. I have seen it in my work environment where people are more interested in solving the tech problem, while the strategic problem is moving beyond, as you were saying, totally correctly. It's moving beyond.
So you talk about the tech problem, and mostly all we talked about here today is electronics and susceptibility of the electronics. Don't forget, in a low Earth orbit, you're susceptible if you have a SIBR type device that's looking for infrared, you're susceptible to a laser blinding, and doesn't take long for a laser on target to blind a sensor. So we have to make sure that the satellite optical system is hardened to that. Also, if you're in low Earth orbit, you're susceptible to atmospheric bulge if an adversary were to do a low altitude detonation. And by low altitude, I guess in this case, I mean 90 to 100 miles. The atmosphere will literally bulge, which will drag the satellites down, plus all the other electromagnetic effects. Mm-hmm. This is so I agree, having a 1 or 2 or 3 year cycle where you can constantly put up newer devices is a great way to go. But then I also think about, do we have the manufacturing ability to do that? Or are we going to have Lockheed do some and Martin Marion to do others and Raytheon do the third? And then what kind of ground control stations do we have? And will we have the training available for the lieutenant colonels to operate these systems? Because if you put up a new system and you now have to have a new way to control it, there has to be training involved. And we may not have time for that lag of expertise.
Mm-hmm. Yeah, no, that expertise lag is and for those who've heard me on podcasts over and over again, and my personal quote, how long does it take to build a 15-year expert? Really fits, because there's a lag in the technology and the understanding. But, I've been around the university systems. I've been around the government labs. There's an incredible effort to do this. I will argue, and without proof, but I think I could talk to many of our leaders in our government that the real delay doesn't come from the ability to build the technology or to understand how the operation strategy. It's all the paperwork and red tape that goes into the logistics chain to get something from point A to point B and get it operationalized. And so, showing that need from a country standpoint. Remember, Manhattan Project, we started with no nuclear weapons, and in 4 years had an operational weapon that we knew. Yeah, 4 years we were able to get a weapon not only designed, built, fielded, but used without testing because we knew it would work. I mean, that's an incredible effort. We're the United States of America. We can do this, and we've got to figure that out. And in fact, the article that I mentioned up front from Atlantic Council that sort of spawned this discussion for today, they had some, at the very end of the article, they talk about some recommendation they've made. And I want to hit number 2 of their list, because I think it's a rather interesting thing to end this podcast, because it's been very interesting discussion. And that is that they mentioned it. One of the argued previously, I'm just reading directly, a whole of government approach is then needed to assess the commercial viability and military utility of those space-based services upon which the U.S. government intends to rely, either wholly or in part, and the government must act to improve the commercial viabilities of these services. And this fits well within the concept that Chris said, that we have dual use capabilities of systems that just need to be designed to also function at operational capability, which is what, Wally, you did for many, many years, that the government pieces were hardened so they would operate, but the GPS or maybe some communication satellites that also had a secondary mission for, I don't know, sending down my Spectrum Mobile or whatever it's supposed to do. That was not an endorsement, by the way. But send me my telephone signal or my TV signal. How do we combine those two so that we build a capability that's also servicing other areas beyond the military operation? Any ideas that you want to throw our audience or hit on this at all? Wally, you look like you're about ready to talk.
So before I retired, why am I doing this? Before I retired, I was working on the other kind of SBIR, small business innovative research. It took forever just to offload a couple $100,000 to somebody with a magic wand that really worked. It is impossible to get things done. The government gets in its own way. And when it isn't being adroit in finding new technologies and funding them, it's changing the way it does business. So it is the second recommendation here from the article is perfect. We need a whole of government thing, but a lot of that's going to mean less government involvement. Give it to 1 or 2 people and get out of the way. Wait until they succeed or fail to help them.
Well, and I'll just add a little 2 cents. It may sound a little cynical, but it's not. It's just a reality. Sometimes when you see in papers we want to have a whole of government approach, many times that's just, they didn't really have anything specific to say. They didn't. And so let's just say, let's have a whole of government approach. And so somebody later will figure it out of which department is going to do what. And to some degree, that's a good idea because you want the administration to have the freedom of maneuver. But at the same time, in the paper that we were looking at, they really didn't talk about defending any of these assets. They were talking about transparency and norm building and diplomacy and all that other stuff, which is all great and all important. And we definitely want a whole government approach using all of our instruments of national power. That's very important. I'm not thrashing that at all. But what I am going to say is that we need to stop trying to avoid the military solutions. We got to have weapon systems that can actively defend and deter against these attacks against these systems. And with going back to red lines again, as they mentioned, where they kind of allude that they think that, if someone shoots a satellite that does NC3 support, that somehow that's going to trigger a nuclear response from the United States. And I don't think it will, because the Chinese don't believe it. They've said so in their writings because of the fact that we're using, again, strategic so-called vehicles for Desert Storm and Forward for tactical use. And so if we're going to have to reestablish some of these red lines, we're going to have to reassert deterrence. Therese Delpech, a French RAND theorist, and Bernard Brody, everybody who's a nuclear person knows who he is from the old RAND days. If you want to reassert a red line, you want to reassert deterrence, that's going to require you to be willing to do some things that normally you wouldn't want to do in order to reassert it, which means if you make a threat, it has to be a credible threat, and you have to be able to follow through on it in order for it to work. Otherwise, we're going to continue to see what we've seen with North Korea, where we allow them to move the status quo line over and over and over again, but only on a bigger worldwide scale with China and Russia. And so we need to be very cautious of that. And you can't do that by transparency and norms because China and Russia don't care about that. They've not been following treaty law. They don't buy into it. And 90% of the stuff the Russians have done, they've also violated too, going all the way back to the Hague Convention in 1890 something. So we need to be realistic. Yes, do the diplomacy, but we need to have military options and solutions. And the Space Force isn't there yet. So that's my concern.
Well, thank you, Chris. That's a good. That was a good dialogue to end on here. Maybe not a very positive dialogue, but certainly a very thought-provoking dialogue. And I'm 100% agreement. That's why I brought this up, because I thought, everyone wants to dance around the issue, but in the end, maybe we need a military, response that looks at those military operational needs in space and focus on that instead of trying to focus on all these other things and combine them in. And that's why I appreciate that response. So we are now beyond our 40-minute time phase. So I'm going to close out this this podcast. Chris Stone, I thank you for joining us today on this podcast. Again, he's our primary speaker for Real Space Strategy. That's his podcast. Twice a month he puts it out, and if you're not listening to it, I'm telling you, you're just really missing out on it. But Chris, I really appreciate all you do for NIDS as one of our senior fellows. Wally Clark, again, he has done several podcasts for what was at one time the Nuclear Review, now the NIDS View as we grow, or NIDS Knowledge, excuse me. And Wally Clark has been also helping us with writing some chapters in our book, the textbook that we have coming up. We also ask our listeners to look at Global Security Review. That becomes my morning review. I review it every morning because there's always new information. And even though it's done within NIDS, I learned something new that I forgot that we were working on. But we're doing that. We're getting out into the community. NIDS is making a real difference. If you haven't seen our new website, come visit us, look at what we're doing, how we're operating, and by all means, come back to this podcast next week for another exciting The NIDS View. And as always, we ask you to think deterrence.
Thank you for listening to the NIDS View. This show is produced under the NIDS Podcasting Network, a division of the National Institute for Deterrence Studies. NIDS is a 501c3 organization dependent upon donations to provide this podcast and bring about awareness of the peacekeeping value of U.S. strength and our national deterrence. You can catch all of our podcasts or provide feedback at thinkdeterrence.com. I would like to thank our producer, Kimberly Charrington, our sponsors, and all the fantastic members of the National Institute for Deterrence Studies for making this podcast possible. Stay tuned next week for another exciting and informative The NIDS View.